Okay, we are almost done. However, we need to talk about one more thing, and that is the Lineweaver-Burke plot. We just talked our way through the traditional Michaelis-Menten kinetics plot and some of the important variables associated with it, right? Km and Vmax. However, working with hyperbolic plots is challenging. You know what's easier than that? A linear plot. And so the Lineweaver-Burke plot is a way for biochemists to linearize data and make it easier to analyze. It is called a double reciprocal plot because if you look at the x-axis and the y-axis, you'll see the x-axis is 1 over substrate concentration. It is the reciprocal of the standard plot, right? Here we just have substrate concentration. And similarly, the y-axis is 1 over initial velocity. Again, the reciprocal of the standard graph. This is why we call it a double reciprocal, because we've taken the reciprocal of both the x and the y coordinates. Now, I show you the equations for this on the slide. Don't need to worry too much about converting the traditional equation to the double reciprocal equation. It's really about what's on this graph. The graph is super helpful. The slope is Km over Vmax, and we know that Km and that Vmax, those are very important variables for us to understand. But even more telling is that the x-intercept and the y-intercept directly tell us the Km and Vmax. The y-intercept here is 1 over Vmax. So the y-intercept is 1 over Vmax. The x-intercept is negative 1 over Km. So we could take each of these data points from the graph and directly calculate Km and Vmax, which is super, super helpful. And this is why plots that linearize the data are so helpful. Now, I want us to keep in mind it is a double reciprocal plot, right, folks? And I know that thinking about fractions is challenging, but basically we need to keep in mind that things are kind of opposite, right? If 1 over Vmax is large, that means Vmax is small. If 1 over Km is small, that means Km is large. So we'll just keep that in our minds. And while these plots are good for linearizing data, of course, they are not perfect. For example, when we linearize the data, you can see that this data kind of all gets squished onto itself. And so this makes finding lines of best fit, for example, a little bit less reliable compared to a plot like this, where you see all of the data points are very nicely spaced out. And then overall, Michaelis-Menten kinetics is a type of kinetics called steady-state kinetics. These are very, very helpful for determining things like Km and Vmax, but they don't tell you things like the mechanism of the enzyme. So other types of kinetics must be utilized to study the mechanism and to determine the mechanism of enzymes. That wraps up our videos for the day, folks. We talked about enzymes binding to substrate. We talked about how reactions can be performed by the protein and or by cofactors. We got into Michaelis-Menten kinetics, and we learned some new vocabulary. Particularly, we learned that catalytic efficiency is the best way to compare two enzymes to each other. And finally, we discussed Lineweaver-Burke plots because they're a really good way to look at data and to determine Km and Vmax. With that, I leave you with this cat meme.